Alright, let's do more human resource machine. Okay, frankly, I fear this level. Okay, 3 swords. It is something pretty straightforward in a higher level programming language, but it is really painful to do in assembly. Well, we'll just give it a try. Okay, I'm not sure how far I'll go. At least I think I can solve it. Okay, solving it shouldn't be a problem within a decent amount of time. Whether eventually we can hit the size challenge or the speed challenge, okay, we'll leave it to luck. Okay, 3 swords. Straightforward problem. Okay, we rank our employee here from worst performing all the way to best performing. Sure, where do we rank? I'll give you some thought while we complete this assignment. Sure. Okay, it means there's only 3 employees or something. Well, at least I see 3, like 2 bosses and myself. Actually there are more, but anyway. Okay, tell me more. Yes, you need to sort sets of numbers. Okay, don't worry, your data resource here have no feeling. Sure. Which we find to be convenient. Yes, of course data have no feeling. Yeah. Right. So I basically take in, not sure whether I want to follow what they have. Okay, usually I like to start new, so let's just start new. Okay, give example. Okay, pretty straightforward. Take 3 input at a time. Okay, sort it from smallest to largest in the outbox. So this one should return 357. The next set should return 358. Then this one is -3, -28. This one is 469. Okay, correct. So that is what we need to do. Alright. Okay. Here goes nothing. Okay. Taking something from the inbox. Copy to here. And just call it value 1. Alright, value 1. Taking from the inbox again, copy to here. I shall call it value 2. Okay, there are a few ways to do this. I think, okay, so one of the way is at this stage we should sort V1, V2 in a certain order. Okay, so what is a good order? Actually I'm not sure. Let's just assume that V1 will be smaller than V2, will be smaller than V3. Okay, let's assume that. Maybe the other way around is more efficient. I don't know. Okay, we'll just choose one and code and see what we get. Okay, and then we'll massage along the way. Alright, so I will want to subtract from V1. Okay, V2 minus V1. I want to check whether this thing is positive or not. Okay, so the else case, if V2 subtract V1 is positive, that means this is in the right order. Okay, V2 is larger than V1. That's good news. Then this is good. Okay, this is good. Else, what do I want to do? Else I want to swap V1 and V2. Swap V1 and V2. Okay, so actually I should copy it later. Okay, I should copy it later. Okay, if this happen, I want to swap V1 and V2. Okay, so in that case, at the end of the whole 6 lines, right, I should get V1 to be lesser than V2, regardless of which one is the first input. Okay, then I'm ready to take a look at the next value. I'm ready to take a look at the next value. Okay, I shall assume that the previous step give me V2. I have V2, okay, at the previous step. Then what do I want to do is okay, actually that doesn't matter because now I have the third input on my hand. Okay, the third input on my hand, I want to subtract V2. Check whether it's negative or not. And then if the input subtract V2 is positive, okay, the else case, then basically it is big. So I want to copy to B3. Okay, this is not really correct. I actually want to subtract and add. Then the order actually cannot. The order actually cannot. I have to be in this order. Correct. I have to be in this order. Whatever happened in between, happened in between. Alright. Okay. So this is good. This is good. Not really too good. Not really too good. Copy to V2. Subtract V1. If I could copy from V1, subtract V2, I will be able to skip a step. I will be able to skip a step. That's true. That's true. Okay, this is what I mean. This is what I mean. Later on, we'll need to come back and tackle the if negative case. Correct? So what we need to do is to jump it somewhere. Okay, this is not powerful enough to amortize. We might be able to do that. I don't think so. Correct? It's not powerful enough to amortize. This is just like the second part. I only take in 2 input. Okay, chances is I need to jump to the end. Okay, and then later jump back. Correct? I need to process and then jump back. So that will take one more jump. Correct, to return here. Alternatively, it will be good if it's negative, we'll just skip some code. We'll write some code here for the positive case. If it's negative, just skip here. So maybe it's a better choice. Maybe it is a better choice for us to do V1 is the largest, this is the largest, second largest, third largest. Okay, we swap the order. What will happen? Okay, we swap the order. Then what should we do then? What should we do then? It means that we should copy from V1, subtract V2. Copy from V1, subtract V2. No, that's not a need. That's not a need. That's not a need. The whole aim is to make it so that that's not a need. Okay, V2 subtract V1. If it is positive, so the else case, then we will need to swap because V1 is supposed to be larger. Okay, that's what I meant. In that case, I will want to swap. Well, how do I swap? How do I swap? How do I swap? There are a few ways. There are a few ways. I can define a temp. I can define a temp. In computing, usually you spell it like that. Okay, but to be more precise, it's like TEMP. Okay, for temporary. Right, temp. What do I want to do to the temp? Okay, if it's positive, okay, V2 minus V1, if it is positive, then I want to store V2 minus V1 to temp. I want to store V2 minus V1 to temp. Okay, I want to add V1. V2 minus V1 add V1 is V2. Correct? I want to copy to V1 because now I want to swap V1 and V2. Okay, the old V2 should be the new V1. Alright, temp is the old V2 minus the old V1. Okay, temp dash temp, and then we add the old V1, it will become the old V2, which is the new V1. Alright, so we have the new V1. New V1 is actually the old V2, right? Okay, this is old V2 minus old V1. So I could subtract temp. Okay, some maneuverability here, but we've seen it before in the earlier level. I've tried it once for an optimized run. Okay, just to see whether that is going to be helpful. Okay, so I have the old V2 value here minus the OV2 plus the OV1. That is the new V2. Okay, hopefully you're still with me, alright? So till here we have what we want. Till here we have what we want. Okay. Okay, then we can jump the whole thing. Alright. So this part of the code, this 5 lines, don't need to be written below and jump back. Okay. Alright, looks good. Looks good. Let's continue. So if I have V3 subtract V2, if it's positive, then V3 and V2 should swap. V3 is actually larger, correct? It should swap. So same thing, I should copy to temp, add, just repeat this thing, but in terms of V2, V3 instead of V1, V2, okay. Copy to V2, subtemp, copy to V3, okay? And that actually swap the two of them. But there's a problem. After swapping, we will actually want to check whether the OV2, the new V2 and V1 are they in the correct order? Correct? If it's not, then we will need to swap them. So copy from V2, okay, because we are having V3 value, sub V1, okay, we want to check whether this thing is negative. Alright, if it's negative, same thing, we should run the top, copy to temp, add V1, copy to V1, sub temp, add no more add, copy to V2, and this will check whether we should swap these two. Okay. Alright, when this is done, V1 is the largest, followed by V2, followed by V3. So what we should do is to copy from V3 outbox, copy from V2 outbox, copy from V1 outbox, and we are ready to repeat the whole thing. Okay, we're ready to repeat the whole thing. Wow, okay, super long, and we are not done yet. Okay, if this part is negative, then we don't need to swap anything. Okay, we don't need to swap V1 with V2. If this part is negative, then V3 is smaller than V2. V3 will be in the correct location, and V1, V2 are already V1 bigger than V2. So once we prove that V3 is smaller than V2, these three values are in the right order. We can immediately jump to the end. Jump to the end. Okay, so we would like to give it a try, see whether the code is correct. Okay, and we will correct from there. Okay, first run seems correct. The next is correct also. Okay, negative numbers. Looks good. Alright, so observe what we are trying to do is to put the largest, second largest, third largest in that order. We sort the three inputs while we put it in. Okay, we're just one above the size challenge. Okay, speed is horrendously over. Okay, this is more or less expected. Actually, the size challenge is a little bit unexpected. I didn't think it's going to be just a little bit above. Okay, I thought it's going to be horribly above. Okay, let's see whether we can cut down on the size. Alright, if we can, that is great. Okay, that is great. So if we can't, then I guess that's too bad. Okay, The jump is pretty well done already, right? Okay, it jumped downward, jump downward. Okay, all the way at the end, then we jump up. I can make things faster by amortizing, but amortizing doesn't save step. Okay, it's something we remember. Amortizing doesn't save step. Alright, there should be somewhere where I could possibly save one step, maybe. Okay, I copy to V1. So actually this code is pretty good. Let's just keep it here, okay, as a template, okay, in case we lose it somewhere while editing. Okay, okay, if I'm to subtract, then I'll copy to temp. Then if I don't use this line, and put it all the way to the end, okay, I may be able to save one, but that is a fake save. I actually needed this one. I needed add V1 and copy to V2. Okay, I cannot do away with this line, even though there seems to be one more at the end. Okay, I couldn't do away with it. That is bad. That's bad. Okay, copy to temp. Add V1. Oh, do I need to copy to temp? V2 minus V1. V2 minus V1. I need it later, right? I need it later. So V2 minus V1 had to go somewhere regardless. Okay? We need to go somewhere regardless. I throw it to temp. Adds V1, copy to V1, sub 10, copy to V2. Looks inevitable. Copy to V3, sub V2. Copy to V3, inbox. That's the third input, right? Okay, sub V2. Same thing, everything in this block cannot be changed. Wait, it cannot be changed. Cannot be changed. Cannot be changed. Cannot be changed. If it's the inbox, I copy to V3 first. Copy to V3 first. It allows me to add. Yeah, that's right. It cannot be changed. It cannot be changed. Okay, could we simplify this part? The last part is the same as the top, so I don't think I can do anything to here. Okay, this is fixed. If anything, I will have to find from here. Otherwise, I'll need to do a different method. Okay, copy to temp. What I want to do is to swap V2 and V3, right? I want to swap V2 and V3. Is there a faster way to do it? Swap V2 to V3. Okay, I can copy from V2. Let's say, copy from V2. Wait a minute, temp. I have a previous value for temp. I have a previous value for temp. I may not have a previous value for temp. It may swap. It may miss temp. Correct? It may miss temp. I may not have a previous value for temp. Alright, I may not have a previous value for temp. So I can't. Okay, I may not have a previous value for temp. I could always make it so that I have a previous value for temp though. Correct? Copy to temp. Okay. V2 minus V1 will always copy to temp. That will increase the step count. But in terms of size, we don't really care. Number of command is exactly the same. Correct? So my temp always will have a value which is V2 minus V1. Which is V2 minus V1. My temp will always have a value which is V2 minus V1. Okay. But this temp could be positive or negative. So it is not exactly helpful to generate V2. No, it's not helpful to generate V2. I wanted to generate V2 using it, so I can save a step here. Okay, 1, 2, 3, 4, 5. It takes 5 steps. It takes 5 steps, and it ends with V2. Could I swap in a way? Okay, this way will edit the V2 first before the V3. Could I do it in a way that edit the V3 first, then the V2? Could I have done that? Could I have done that? Copy to temp. This is V3 minus V2. V3 minus V2. Then I copy from V2, copy to V3. V3 minus V2 and add temp. I could do that. Okay, I could do that. This part, what it does is to swap V2 with V3, correct? Swap the both of them. An alternative way to do the swap is to this is what I mean. Alright, what I'm trying to do here is to swap V2 and V3, correct? Okay, an alternative way I could do the same to swap V2 with V3. Okay, is that I think the copy to temp we cannot avoid. Okay, this is the OV3 minus OV2. Okay, the over value. Alright, after that I copy from V2, copy to V3. V2, OV2 become the new V3. Okay, OV2, this is V3 minus V2. Okay, OV2 plus OV3 minus OV2 will give us the OV3. Okay, OV3 should be the new V2. Copy to V2. Nice. These 4 lines replicate this 1, 2, 3, 4. Okay, 1, 2, 3, 4 lines, correct? 4 lines, because the copy to temp I extracted out. Okay, this 4 line does the same as these 4 lines. Same. The only difference is I do V2 first or V3 first. Okay, this one do V3 first, then V2. This one do V2 first, then V3. The benefit of the first method is immediately after this I need the V2 value, correct? I can save this one step. So I will remove one. Oh, maybe I shouldn't remove that one so fast. Okay, that one acts like a marker. Alright, I could remove 1, 2, 3, 4, which is covered by the first 4, and by the end of it I actually have V2. I can remove this one, 5. Okay, and I replace it with 4. Let's run. Okay, it looks correct so far. Finger crossed. I think we have the correct size. Yes, we have the correct size. Okay. Wow. Nice. This whoa is a pain. Okay. It's nice that we have the size. Okay, speed is horrendously over. Frankly, I don't really remember reading the speed number. Sorry about that. Let's read. But I think it's horribly over. Okay, it takes what, 78? Let's see whether I remember the number. 78 steps, but I spent 110 plus step or something. Okay, let's check. Okay, 78 step, I took 103. Okay, because I reduced one step. Okay. 103, that is like happily 25 more. 25 more. Okay, that will pose to be a problem. Okay, so we just store. This is a size challenge. Okay, it successfully does a size challenge. Okay, let's paste here. This one we don't need. It is a good checkpoint. Alright, and then let's do a speed challenge. Alright, speed challenge. Can we just use this code, or we have to change the code? Okay. Just for labeling sake, maybe I should label for the benefit of my viewers. Okay. Benefit of my viewers. Alright, V1 swap V2. Okay, this part swap V1 and V2, this part swap V2 and V3, this part swap V1 and V2, and then we will have V1 to be largest, second largest, third largest. Alright, this is a move and swap strategy. Okay, for the speed challenge, we are going to think about what is best. What is best? Maybe then I should start from scratch. Okay, let's start from scratch. Alright, let's start from scratch. What is the most efficient step to do? Okay, we don't care about the number of commands we are going to use in the end. Just go for the most efficient steps. Okay, take from the inbox, copy to V1. I think we have to store V1 no matter how. Okay, take from the inbox. Alright, instead of copying to V2, we just directly compare. We want to save step, right? Okay, so we just compare with V1. Okay, it could be positive or negative. Alright, so let's say V2 is actually smaller than V1. How do we do it? We did it such that V1 is larger than V2. V1 is larger than V2 just now. Okay, so let's see. Okay, the swapping step is very painful. Okay, one way is we could just hard code the result. Correct? We could just hard code the result. Think about it this way. Instead of swapping them, we know that we are just comparing 3 values. Correct? So we are going to just branch out all the possibilities. Okay, and code the ordering. Wow, the number of commands is going to explode. But I think that's the fastest because there is no swap involved. Okay, we are not going to swap. We are just going to return in order. Okay, so copy to inbox, copy to V1, subtract V1. Okay, then I can actually directly just copy to V2 anyway, doesn't matter. Subtract to V1, that is the first branch. V2 minus V1, if it's positive, the else case. If it's positive, we should swap. That means V2 is larger than V1. Okay, so let's remember V2 is larger than V1. Okay, let's take the next value in the inbox, copy to V3, subtract, jump is negative. Okay, this means that the else case means that V3 is larger than V2. So when V2 is larger than V1, V3 is larger than V2, we know the order. Okay, this is the smallest, second smallest, third smallest. Immediately we can copy from V1 our box, copy from V2 our box, copy from V3 our box. Wow, this is crazy. Alright, this is crazy. I'm going to repeat this so many times. Alright, and then we are ready to take a look at the next set of inbox value. Okay, once this is done, what happens if we have negative? Okay, we don't care about amortization first. Likely really hard to amortize. Okay, so let's not care about amortization. Okay, if it's negative, that means V2 is smaller than V3. Then we should compare between V1 and V3. Correct? Copy from V3, subtract V1. Alright, if it's positive, then how? If it's positive, that means V3 is larger than V1. Correct? V3 is larger than V1, and that would means that V1 is smallest, followed by 3, followed by 2. So we outbox. Wow, copy from 1, outbox. Copy from 3, outbox. Copy from 2, outbox. We have done 2 ordering. I think there's a total of 6 of them. It's madness, okay? And once this is done, we are ready to go back and take a look at the next set of input. Alright, what happened if this part is negative? If this part is negative, that means V3 is the smallest, so 3, 1, 2. 3, 1, 2. Okay, jump to the end, copy from 3, outbox. Copy from 1, outbox. Copy from 2, outbox. And we're ready to go back and take a look at the next cell input. Wow, madness. I am hard coding the result. There are 6 of them. Okay, I'm going to see whether this satisfies the size challenge. Okay, but before anything, we don't do this in real life. Okay, this is really very fixed function. Unless it really run fast, we'll verify soon. Okay, does it run fast? But the thought readability is really bad, and it basically just code out all the possibilities and thus the function not really extendable, so it's very hard to extend to a 4 input or sort, 4 sort. Okay, it can only work for this 3 sort. That's all. Okay, anyway, I shall not complain. If this doesn't even meet the size challenge, then I can just throw out this idea. But it will be very weird if it doesn't. Well, it really saves a lot of steps compared to sorting. Okay. Anyway, so I've coded 3 situation already. Okay, let's continue. This one, another big one. Okay, so if V2 subtract V1 is negative, that means 1 is larger than 2, correct? 1 is larger than 2. 1 is larger than 2, we are going to inbox. Recall, we haven't taken the third value by this jump, correct? We haven't taken the third value by this jump. So we need to take in inbox, copy to V3. Alright, what we have is that 1 is larger than 2, correct? 1 is larger than 2. V2 subtract V1 is negative. So 1 is larger than 2. Okay, 1 is larger than 2. Immediately we want to check. This time we subtract V1. 1 is larger than 2. We want to check whether 3 is larger than 1. If 3 is larger than 1, immediately 1 larger than 2. So the order is 2, 1, 3. Whoa. Copy from 2, outbox. Copy from 1. I can't believe I'm doing this. Outbox. Copy from 3. I must be really desperate. Okay. Yeah, it must be really desperate. Okay, I'm ready to jump back to the top. How many Ks have I coded? 4 Ks. 2 more to go. Okay. 2 more to go. If this is negative, what happened? It means that 3 is lesser than 1. 1 is the largest. So we don't know 2 or 3 which one is larger. Correct? So we need to copy from 3. Subtract 2. Jump is negative. The positive case means 3 is larger. That means 2, 3, 1. Oh. 2. Outbox. 3. Outbox. 1. Outbox. We haven't had 2, 3, 1, right? I think so. We haven't had it. Okay. 2, 3, 1. Jump. 5Ks. Last one. Last one. If this is negative, okay, it means that 3 is smallest. Okay, 3 minus 2, right? So 3 is smallest, smallest, second smallest, third. 3, 2, 1. We haven't had that, right? 3, 2, 1, 3, 2, 1. Okay, and that's all the combination. 3, 2, 1. Alright, here it is. Copy from 3 outbox. Copy from 2 outbox. That's the last case. I will soon know whether I'm wasting my time. But it seems like a good idea. Actually, intuitively, I think it saves that. Okay. Okay, here goes nothing. I didn't use the temp. Let's delete away temp. We'll delete away later. Okay, let's try. That feels pretty fast. Fails on other input. Okay. This input will fail. That's it. I coded this one wrong. It should have been 349. I coded it as 4 first. So 349 is a 312. The 312 case is wrong. I did a 1 first. Let's check. 312 case is wrong. Okay. Let's verify all the cases. Alright. Here, if it's positive, it means that 2 is larger than 1. Okay, 2 is larger than 1. Copy to 3. Wait a minute. Copy to 3. I don't care whether 3 is negative or not. I should subtract 2. Correct. That's what I actually want. Will that solve things? Let's try. Will that solve things? Oh, that's the mistake. Alright. Whoa. Sure. Yes! Whoa! Yes! Oh, it barely hit. That means this thinking may be correct. We should not do swap. Swap is really painful. Okay, as you see, that's really an overshot just now. Without swaps, then we can reach this. Okay, just 3 below. Chances is yeah, we need something like this. We need something like this. Okay. Wow, interesting. Maybe the 3 give us a chance to not do this kind of maneuver. Okay, basically I directly compare. Maybe I could just read in V1, V2, V3 at a go, then compare them separately. Okay, and that should still hit within the speed challenge. Wow, impressive. I didn't use this by. Okay, wow, I got it, right? I got it. This is the speed. This is the speed. Wow. Okay. For sure, still painful. It doesn't change my view on this level. Okay, I'm surprised I got both the size and the speed. And wow, it's going to stay in my memory as the very painful level. Okay, that's it for 3 swords. I hope you enjoy seeing me suffer. Okay, if you know, seeing a good balance between suffering and achieving the results is something you like in a puzzle gaming video. Okay, do like and share. Also subscribe to my channel. Okay, I'm going to do more of this kind of video. I think the way I play has good structure to a certain extent. Okay, and it should be enjoyable. Alright, so Papa is done. Enjoy.